Welcome, curious minds, to this gentle journey through the vast wonders of space travel. As a physicist who delights in unraveling the universe's mysteries, I will guide you step by step through 100 fascinating facts, starting with the very beginnings that sparked humanity's reach for the stars. Picture the early 20th century, when visionaries like Konstantin Tsiolkovsky dreamed of rockets piercing the atmosphere, much like a child sending a kite soaring into the wind. Tsiolkovsky, often called the father of astronautics, realized that to escape Earth's gravity, we needed vehicles propelled by the precise balance of thrust and mass, a concept as elegant as a feather floating on a breeze. His equations, which I like to think of as the gentle blueprints of flight, showed that rockets could carry us beyond our planet by converting chemical energy into motion, pushing against the air with a force that mirrors how a sailboat glides across water. As we delve deeper, consider the first actual flights that turned dreams into reality. In 1926, Robert Goddard launched the world's first liquid-fueled rocket, a modest contraption that rose a mere 184 feet, yet it opened the door to the cosmos in a way that felt almost poetic. This was not just engineering, it was a testament to human curiosity, where the physics of propulsion, think of it as carefully timed explosions creating upward momentum, allowed us to challenge the pull of gravity. Over the decades, programs like NASA's Mercury and Gemini missions built on these foundations, sending humans into orbit and proving that our bodies could withstand the vacuum of space, much like a deep-sea diver adapting to the ocean's depths. Each fact here paints a picture of progress, from the V-2 rockets of World War II, which, despite their troubled origins, advanced our understanding of high-altitude flight, to the Sputnik satellite in 1957, the first human-made object to orbit Earth. It is a reminder that space travel begins with small steps, each one a harmonious dance of science and imagination, inviting us to ponder the beauty of how we have learned to leave our world behind. Moving forward, we will explore how these early achievements laid the groundwork for more ambitious voyages, where the elegance of physics continues to shine. The development of multi-stage rockets, for instance, allowed for greater payloads and speeds, akin to a relay race where each runner passes the baton to go further. Facts like the Apollo 11 mission in 1969, where Neil Armstrong's first steps on the moon symbolized humanity's leap, highlight the precision required, orbital mechanics ensuring a safe return, much like a boomerang's arc. Through it all, I want you to feel the warmth of discovery, knowing that every fact we are uncovering is part of a larger, interconnected story of exploration that soothes the soul as much as it educates the mind. Rockets and the physics of launch. As we build on the foundations of those pioneering flights, let's turn our attention to the intricate world of rockets, where physics transforms raw energy into the grace of ascent. Imagine a rocket as a colossal slingshot, harnessing Newton's laws to defy gravity's embrace, propelling us upward with a force that is both powerful and precisely controlled. The first fact to consider is how rocket engines work through the principle of action and reaction, where expelling hot gases downward creates an equal and opposite thrust upward, similar to how a balloon zips across a room when you let go of the air inside. This conservation of momentum, a cornerstone of classical physics, ensures that even in the vacuum of space, a rocket can keep moving, guided by the elegant simplicity of equations that balance mass and velocity. Delving deeper, we encounter the multi-stage design of modern rockets, a clever innovation that sheds weight as fuel is burned, allowing for greater efficiency and reach. Take the Saturn V, for example, which carried astronauts to the moon. Its 3 stages fired sequentially, much like a series of waves building upon each other in the ocean to carry a surfer farther ashore. Each stage's separation is a ballet of engineering, reducing mass to accelerate faster, and this fact underscores the beauty of optimization in physics. every pound saved means miles gained toward the stars. Another fascinating detail is the role of aerodynamics during launch, where the rocket's shape minimizes air resistance, akin to a bird streamlining its body for flight, ensuring that the initial climb through Earth's atmosphere is as smooth as possible. Continuing this thread, let's not forget the thermal challenges rockets face, with heat shields protecting against the friction of re-entry, a phenomenon I like to compare to a pot of water boiling over but contained just right. Facts about materials like ablative shielding, which vaporize to carry away heat, reveal the poetic interplay between matter and energy, keeping crews safe on their return. As we weave through these insights, it is clear that rockets are not just machines. They are embodiments of physical laws that make the impossible seem attainable, drawing us ever closer to the cosmos with each launch. Orbiting the Earth and satellite technology. From the thrilling launches, our narrative naturally flows into the realm of orbits, where satellites circle our planet in a perpetual dance, held by gravity's invisible threads. Think of an orbit as a carefully balanced path, much like a stone swung on a string, where the satellite's forward speed exactly matches the gravitational pull, keeping it suspended in space without falling back. This concept, rooted in Kepler's laws, shows how elliptical paths allow for precise positioning, enabling everything from weather forecasting to global communications, and it is a testament to the elegance of celestial mechanics that governs these motions. As we explore further, consider the myriad types of satellites and their purposes, each one a floating laboratory or observatory. Geostationary satellites, for instance, hover over the same spot on Earth by matching our planet's rotation, providing constant coverage for television signals, similar to a watchful guardian staying in place. Facts about the International Space Station highlight how these orbits facilitate human presence in space, with astronauts conducting experiments in microgravity, where fluids behave differently and crystals grow purer, offering insights into materials science that could revolutionize life on Earth. It is all about the gentle interplay of forces, where the physics of freefall creates an environment for discovery. Building on this, we cannot overlook the challenges of maintaining orbits, such as orbital decay caused by atmospheric drag, which requires periodic boosts from onboard thrusters. Picture it like pedaling a bicycle to keep going uphill. Without that extra push, friction would slow things down. These facts underscore the ongoing maintenance needed to keep our technological eyes in the sky, ensuring they continue to beam back data that enhances our understanding of the universe. The human element in spaceflight. Transitioning seamlessly from machines to the people who command them, we now delve into human spaceflight, where the physics of the body meets the vastness of space. Imagine astronauts as intrepid explorers, adapting to weightlessness, where every movement floats freely, a direct result of being in free fall around Earth, much like leaves drifting on a lazy river. This microgravity environment affects everything from bone density to fluid distribution, and facts about training programs reveal how simulations prepare crews for these changes, using centrifuges to mimic G-forces during launch and re-entry. As we unpack more, consider the physiological adaptations required for long-duration flights, such as on missions to the Moon or Mars. The human heart, for example, works harder in space to pump blood against the lack of gravity, leading to potential muscle atrophy that astronauts counter with rigorous exercise routines. It is a beautiful illustration of biology and physics intertwining, showing how our bodies, governed by the same laws that propel rockets, must evolve to thrive beyond our atmosphere. Stories from Apollo missions highlight the precision of life support systems, where oxygen recycling and temperature control create a habitable bubble, akin to a terrarium sustaining life in a desert. Further, The psychological aspects add depth, with isolation and confinement testing mental resilience, yet fostering a profound connection to the cosmos. Facts about spacewalks, where tethered astronauts venture outside their vessels, demonstrate the careful orchestration of momentum and air pressure to avoid drifting away, a delicate balance that echoes the universe's own harmonies. Life aboard space stations. Carrying forward from the adventures of individual flights, our story now embraces the ongoing saga of space stations, those orbiting outposts where science and daily life merge in microgravity. Picture the International Space Station as a bustling home in the stars, where crews conduct experiments while floating from module to module, all thanks to the constant free fall that defines their environment. Here, physics plays a starring role in everything from water management, where surface tension keeps liquids in place without gravity's help, to the way solar panels harvest energy, converting sunlight into electricity with an efficiency that rivals the most advanced earthly tech. Diving deeper, facts about the station's construction reveal the intricate orbital rendezvous maneuvers, where modules are docked with pinpoint accuracy, much like pieces of a puzzle snapping together in mid-air. This process relies on thruster adjustments to maintain the right velocity, ensuring the station remains a stable platform for research into phenomena like crystal growth or protein folding, which behave differently without gravity's interference. It is a gentle reminder of how space travel advances medicine and materials science, all while providing a live-in laboratory that orbits Earth every 90 minutes. As we continue, the daily routines of astronauts aboard highlight the physics of sustainability, from recycling air and water to generating power from the sun. These facts paint a picture of human ingenuity, turning the harsh void into a haven of discovery. The dangers and challenges of space. As we press on from planetary quests, it is essential to acknowledge the dangers that accompany space travel, where the universe's beauty hides formidable physics-based hazards. Think of cosmic radiation, a stream of high-energy particles that can penetrate spacecraft, much like sunlight filtering through leaves, but with potentially harmful effects on human cells. Astronauts mitigate this with shielding and timed exposures, drawing from facts about the Van Allen belts, Earth's magnetic defenses that trap radiation and must be navigated carefully during launches. Exploring further, the risk of micrometeoroids, tiny specks traveling at high speeds, poses a threat to hull integrity, requiring reinforced materials and collision avoidance systems. It is a stark reminder that space is a vacuum where a hull breach could lead to rapid decompression, and emergency protocols ensure survival in such scenarios. These challenges highlight the resilience needed, blending physics with human determination. Visions of the future in space travel. Building upon the obstacles overcome, our narrative shifts to the future of space travel, where innovative concepts promise to expand our reach even farther. Envision reusable rockets like those from SpaceX landing vertically after missions, recycling hardware to make journeys more sustainable, much like reusing a favorite tool for multiple tasks. Facts about nuclear propulsion hint at faster travel times, using atomic energy to achieve higher speeds, potentially shortening trips to Mars from months to weeks. As we continue, ideas like space elevators, tethers reaching from Earth to orbit, offer a gravity-free ascent, though they remain conceptual, relying on advanced materials to withstand tensions. This future is filled with the elegance of physics, making dreams tangible. Interstellar ambitions and beyond. From near-term visions, we venture into interstellar ambitions, where traveling to other stars involves overcoming vast distances with revolutionary physics. Consider warp drives, theoretical bubbles bending space-time, allowing faster-than-light travel in theory, akin to folding a map to bring points closer. Facts about current probes like New Horizons provide a glimpse, pushing the boundaries of our solar system. The impact of space travel on Earth. Finally, circling back to how space travel shapes our world, we see its profound impacts on society and technology, from GPS systems guiding daily life to materials derived from space research. This gentle conclusion ties together the wonders we have explored, leaving you with a sense of awe. Well, the intricacies of rocket propulsion. Building on the journeys of space probes, let's now ease into the heart of what propels them. Rocket propulsion, a symphony of force and fuel that echoes the simple push of a balloon released into the air. Picture a rocket as a colossal version of that balloon, expelling gas at high speeds to thrust itself upward, defying Earth's pull through Newton's third law. Every action has an equal and opposite reaction, like two friends pushing off each other on ice skates to glide apart. This principle, foundational to physics, allows us to escape gravity's embrace, turning the impossible into the achievable with elegant precision. Early rockets, like those designed by Robert Goddard in the 1920s, were rudimentary, but they have evolved into sophisticated machines, such as the Saturn V that carried astronauts to the moon, standing tall as a testament to human ingenuity. In modern times, engines like those in the SpaceX Falcon 9 recycle and reuse, much like borrowing a bicycle for multiple trips, making space travel more sustainable and cost-effective. Inside these engines, chemical reactions release energy in a controlled burn, heating propellants to create a roaring exhaust that propels the rocket forward. It is akin to boiling water in a kettle. The steam builds pressure and escapes, but on a rocket, it is channeled to produce immense power. This process involves thermodynamics, the study of heat and energy transfer, which we can think of as the body's way of maintaining balance, ensuring that no energy is wasted in the vast cold of space. As we ponder these mechanisms, we are drawn to the beauty of efficiency, where every drop of fuel serves a purpose, mirroring the universe's own conservation laws. Through rocket propulsion, space travel becomes not just a feat of engineering, but a gentle reminder of how physics weaves simplicity into complexity, inviting us to appreciate the quiet power that carries us toward the stars. 14. The mysteries of black holes and their exploration. Transitioning from life's necessities in space, let's gaze into the profound mysteries that draw us outward, such as black holes, those enigmatic gravitational wells that warp space and time like a heavy ball on a stretched bedsheet. Exploring these phenomena through space travel involves telescopes and probes that peer into the universe's darkest corners, revealing truths that feel almost poetic. The Event Horizon Telescope, for instance, captured the first image of a black hole's shadow in 2019, akin to spotting a hidden whirlpool from afar, using radio waves to piece together a puzzle of immense gravity. This achievement relies on general relativity, Einstein's idea that massive objects bend spacetime, much like a boulder altering a river's flow, pulling everything toward it inescapably. As we consider missions like those planned for the James Webb Space Telescope, we are reminded of how space travel unravels these cosmic enigmas, studying black holes' effects on nearby stars and galaxies. It is a gentle unfolding of the universe's story, where physics' elegance shines through in the invisible forces at play. Black holes are not just voids, they are crucibles of energy, recycling matter in ways that echo the cycle of seasons on Earth. By sending our instruments into their vicinity, we learn about the universe's origins and fate, all while appreciating the reassuring scale of it all, vast yet intimately connected to our own existence. This exploration invites a sense of calm awe, transforming the intimidating into the wondrous. 15. The role of satellites in global communication. From the depths of black holes, our journey shifts to the practical magic of satellites, orbiting sentinels that weave a web of communication around our planet, much like a spider's silk connecting distant leaves. These artificial moons enable instant global connectivity, from video calls to weather forecasts, by bouncing signals across vast distances with the reliability of a well-tossed boomerang. Launched into geostationary orbits, where they hover above the same spot on Earth, satellites maintain their position through a balance of gravity and centrifugal force, similar to a child spinning a top that stays upright amid motion. This equilibrium, rooted in classical mechanics, ensures uninterrupted service, fostering a world that is more interconnected and harmonious. Consider how the GPS system, a constellation of satellites, guides your daily drives by triangulating your position using radio signals. It is like using echoes in a canyon to pinpoint your location. Originating from space travel technologies, this network not only aids navigation, but also supports scientific endeavors, monitoring climate change and natural disasters. The beauty lies in the precision and subtlety of physics, where even the slightest orbital adjustment keeps everything in sync. As we reflect on satellites' contributions, we are enveloped in a warm sense of unity, seeing how space travel bridges gaps and brings the universe's elegance into our everyday lives. 17. Asteroid mining and resource utilization. From the gear that safeguards explorers, our story naturally extends to the future promise of asteroid mining, where space travel could unlock cosmic resources, much like panning for gold in a distant stream. Picture asteroids as floating treasure troves, rich in metals like iron and platinum, which we might one day harvest to fuel further adventures, all guided by the precise orbits calculated through celestial mechanics, the same physics that keeps planets in their paths. Missions like NASA's OSIRIS-REx, which collected samples from an asteroid, demonstrate how we gently interact with these bodies, using robotic arms to scoop material without disturbing the delicate balance of space. This endeavor relies on energy conservation and propulsion systems to reach these wanderers, thinking of it as a game of catch with moving targets across the solar system. The potential benefits are profound, providing materials for space habitats and reducing Earth's resource strain, all while unveiling the universe's abundant generosity. Physics here reveals its poetic side, showing how gravity and motion can turn scarcity into opportunity, inviting us to ponder the interconnected web of the cosmos with a sense of peaceful optimism. 18. The impact of space travel on climate science. Shifting our focus to how space travel aids our home planet, consider its crucial role in climate science, where satellites act as vigilant observers, monitoring Earth's atmosphere like a doctor checking a patient's vital signs. These orbital eyes track carbon dioxide levels and ice cap melting, using infrared sensors to detect heat patterns, much like feeling the warmth of a fever with a hand on the forehead. This data, gathered through principles of remote sensing, helps us understand global warming's rhythms, revealing the delicate interplay of energy and climate systems. Space travel's contributions extend to predicting weather with accuracy, employing physics to model atmospheric flows, similar to watching ripples in a pond expand from a dropped stone. By integrating this knowledge, we are better equipped to protect our world, all while appreciating the elegant harmony between space exploration and earthly care, fostering a deeper, more reassuring connection to the universe. 19. The psychological effects of space on astronauts. As we weave through the threads of space travel's influences, let's turn to the human mind in space, where astronauts face psychological challenges that mirror the isolation of a quiet retreat, yet are managed with supportive strategies. Think of microgravity as a blank canvas, altering perception and routine, much like adapting to a new room in a familiar house. Physics plays a role in these experiences, from the disorienting effects of zero gravity on balance to the way light and time bend in orbit. Through training and communication, we ensure mental well-being, highlighting the beauty of resilience in the face of the unknown and leaving us with a warm sense of human triumph. 21. The dance of gravity wells in interplanetary journeys. As we linger on the dream of human outposts beyond Earth, it is worth pausing to appreciate how gravity, that invisible force we feel every day when we drop a book or sip from a cup, plays a starring role in space travel. Imagine gravity not as a stern pull downward, but as a gentle current in a vast cosmic river, guiding spacecraft along efficient paths through the stars. In the realm of physics, this is the essence of gravitational assists, where a probe swings by a planet like a child on a swing, gaining speed from the planet's gravitational tug without expending extra fuel. It is an elegant ballet, really, where the sun and planets choreograph the movements, allowing us to visit distant worlds with remarkable thrift. Take the Voyager missions, for instance, those intrepid explorers that have journeyed farther than any before. By harnessing the gravity of Jupiter and Saturn, they accelerated onward, much like a surfer catching a wave to glide effortlessly across the ocean. This technique, rooted in Newton's laws of motion and gravity, saves precious resources, making long voyages feasible. Without it, sending probes to the outer planets would be as impractical as trying to row a boat across the Atlantic without wind or current. Yet it is not just about saving fuel, it is about the beauty of interconnectedness in the universe, where everybody's mass influences the path of another, creating a symphony of orbits that physicists can predict with stunning accuracy. As we contemplate these journeys, remember that gravity is our ally, a wise companion that whispers directions through the void, helping us unravel the mysteries of space with grace and precision. In this gentle unfolding, we see how physics transforms the overwhelming scale of the cosmos into something approachable, almost poetic. Picture a spacecraft dipping into a planet's gravitational well, emerging faster and more directed, all while the stars wheel overhead in their eternal dance. It is a reminder that even in the vast emptiness, there is an underlying order, a harmonious design that makes exploration possible. So, as we build toward those Martian cabins, let's cherish this fundamental force, for it holds the key to venturing further, fostering a sense of wonder that soothes the soul amid the infinite. 33. Life support systems. Nurturing humans in the void. From the paths we trace through space, our thoughts naturally drift to sustaining life amid the stars, where life support systems become the unsung heroes of exploration. Picture these as a cosmic greenhouse, carefully balancing air, water, and warmth to mimic Earth's embrace, all while drifting far from home. In physics, this involves thermodynamics and closed-loop systems, where energy and resources are recycled with the efficiency of a well-tended garden, preventing the harsh vacuum from overwhelming fragile human needs. Consider the International Space Station, a bustling orbital home where astronauts recycle their own breath and waste, turning exhaled carbon dioxide back into oxygen through clever chemical processes, much like leaves in a forest absorbing and transforming gases. This closed ecosystem relies on principles of conservation of mass and energy, ensuring that nothing is wasted in the isolated confines of space. It is a gentle reminder of how physics mirrors nature's cycles, providing a safety net that feels almost nurturing, allowing crews to focus on discovery rather than survival. The beauty of these systems lies in their adaptability. For longer missions, like those to Mars, we might draw on solar power to electrolyze water into breathable air, harnessing the sun's rays as a reliable, eternal friend. Think of it as drawing energy from a campfire on a cool night, sustaining warmth and light without depleting resources. This approach not only conserves supplies, but also embodies the elegance of equilibrium, where inputs and outputs balance in a harmonious flow. In contemplating life support, we are invited to see space travel as an extension of our own world, a place where physics helps us create pockets of familiarity in the unknown. It is comforting to know that, even in the vast emptiness, we can engineer environments that feel like home, fostering a sense of security that encourages exploration. As we envision future outposts, these systems stand as a testament to human ingenuity, turning the challenges of space into opportunities for growth and wonder. 25. Beyond chemical rockets. Innovative propulsion ideas. Shifting from the human element, let's explore the engines that drive us forward, moving beyond traditional chemical rockets to more inventive propulsion methods that promise smoother, farther-reaching voyages. Imagine these as sails catching stellar winds, harnessing the universe's own energy rather than relying solely on explosive bursts, all grounded in the physics of motion and energy transfer. One such idea is ion propulsion, where electrically charged particles are accelerated to high speeds, providing a steady, gentle push over long distances, much like a leaf being carried by a persistent stream. In physics, this leverages electromagnetism and Newton's third law. Every action has an equal and opposite reaction, allowing spacecraft to gain speed gradually without the massive fuel loads of conventional rockets. It is an efficient dance, where small thrusts add up over time, making missions to the outer solar system feasible and elegant. Then there is the concept of solar sails, vast, lightweight sheets that reflect sunlight for propulsion, propelled by the pressure of photons, just as a boat is by wind. Drawing from relativity and quantum mechanics, this method turns the sun's radiation into a free, renewable force, offering a poetic symmetry in our cosmic travels. While still experimental, it is a testament to physics' creativity, transforming light into motion with minimal complexity. Embracing these innovations, we find a reassuring path forward, where propulsion becomes less about raw power and more about harmonious interaction with the universe. This not only extends our reach, but also highlights the beauty of efficient design, inviting us to journey with a sense of ease and anticipation. 26. Whispering across the void. Space communication challenges. As our spacecraft venture deeper, the challenge of staying connected comes to the fore, much like sending letters across a vast ocean where delays and distances test our patience. In physics, this involves the speed of light and electromagnetic waves, ensuring that signals travel reliably through the emptiness, carrying data from probes to Earth with the precision of a well-timed conversation. Radio waves, the backbone of space communication, propagate at light speed, meaning a message from Mars might take minutes to arrive, akin to waiting for an echo in a distant valley. To overcome this, engineers use deep space networks, arrays of massive antennas that amplify faint signals, drawing on principles of wave interference to clarify transmissions. It is a gentle process where physics turns potential isolation into a bridge of understanding, fostering collaboration across millions of kilometers. The elegance lies in error correction and data compression, techniques that ensure every bit of information is preserved, much like proofreading a letter before sending it. This allows us to receive stunning images and scientific insights, reminding us that even in silence, the universe is full of stories waiting to be told. 28. The Quest for Alien Worlds. Searching for life beyond Earth. In our pursuit of the unknown, the search for extraterrestrial life ignites wonder, using telescopes and probes to scan for signs of biology in distant realms. Physics underpins this with spectroscopy, revealing planetary atmospheres, like reading a book's pages from afar, fostering a sense of shared cosmic heritage. 29. Global Partnerships, the human network in space exploration. Space travel thrives on international cooperation, blending diverse talents to achieve shared goals, much like a symphony orchestra harmonizing notes. Physics provides the common language, from trajectory calculations to satellite designs, uniting us in a global embrace of discovery. 30. Horizons of space tourism, everyday adventures among the stars. Finally, envisioning space tourism opens doors to accessible wonders, where physics makes orbital flights routine, like a scenic drive through the heavens, inviting all to share in the universe's gentle marvels.